Okay, in this video, we're going to be going through the Algebra 1 Unit 1 study guide. So you need to kind of check your answers as you're watching this. So number 1, it says to simplify the square root of 200. Now before we go through and we start simplifying, let's talk about those perfect square numbers again. You're going to need to know that these are the numbers that I use to divide in to the number under the radical to simplify. They are 4 because 2 times 2. 9 because of 3 times 3, 16 because of 4 times 4, 25 because of 5 times 5, 36, 6 times 6, 49, 7 times 7, 64 for 8 times 8, 81 for 9 times 9, 100 for 10 times 10, 121 for 11 times 11, 144 for 12 times 12. So 200, so I'm going to simplify it. So I've got my square root of 200. Now I need one of these, the biggest number that will divide into 200. 4 will, but there's a bigger one. 25 will, but there's a bigger one. I want the biggest number. 100 divides into it. 100 times 2. Okay, then 100 is a perfect square, so it goes away. What number times itself is 100? That is 10, and then the square root of 2 just stays, 10 square roots of 2. Okay, number 2, simplify then subtract. Remember when we're adding and subtracting radicals, we have to have the same radicand. Now, the radicand is the number up under the square root symbol. So here my radicands are 18 and 8. They are not the same. So I need to first of all simplify these. Okay, so I'm going to come out here, the square root of 18. So I need, again, one of these red numbers that will divide into 18, the biggest one. That's 9 times 2. Well, the square root of 9 is 3. So now my problem is going to look more like 3 square roots of 2. Okay, because this turned to a 3. And then I'm going to do the same thing with the square root of 8. The biggest number that will divide into it is 4 times 2. The square root of 4 is 2. So I'm going to get minus 2 square roots of 2. Now if we look, our radicands are the same. They're both 2. So I can subtract. And when I subtract, I only subtract the outside numbers. So 3 minus 2 gives me 1 square roots of 2. Or just so you know, they don't have to have the 1, and the square root of 2 works as the answer as well. Okay, a rational number. Okay, what is a rational number? Okay, it is any number that can be written as a fraction. So any number that can be written as a fraction. Remember, decimals end and repeat. Okay, and that's what I just said, a repeating decimal, okay, a decimal that keeps repeating over and over is a rational number. It is rational. Okay, so 4.032, is it rational or is it irrational? It is rational, and the reason why, because the decimal ends. It stops, it terminates. Okay, which of the following numbers is irrational? And I'm going to put them up here so we can see our choices. Our choices were, on our quizzes, square root of 8, 2 3/4, and negative 1.325. Okay, remember, we're wanting irrational, but we know rational is anything that can be written as a fraction. So 2 can be written as a fraction. It is rational. I might make a note of that. It is rational. 3/4 can be written as a fraction. It is a fraction. It is rational. I also said a rational number is any decimal that ends. Well, negative 1.325 ends. It is rational. So the only one left is the square root of 8. Irrationals are those non-perfect square roots. 8 is not a perfect square root, so it is irrational. So the square root of 8 would be our irrational number. Okay, we have a rectangle that has a length of 14 meters and a width of 200 centimeters. What is the perimeter in centimeters? Okay, so I'm going to draw me a rectangle first of all. And that's not a very good rectangle. Okay, and I know that I have a length of 14 meters and a width of 200 centimeters. Now I want my answer here in centimeters, which means I'm going to have to change that 14 meters to centimeters. So if we think about our stepping blocks, I'm going to draw them over here. Here is my basic, my meters. And then if I go down one, I'm at deca. And if I go down another one, I'm at centi. Okay, so that means that I have moved down smaller 2 places. So that means I'm going to take my decimal. I'm going to take this 14 point. And I'm going to move it 2 places to the right. 1, 2. So that is actually, instead of 14 meters, is 1400 centimeters. Now to find the perimeter, I add up all my sides. So this one's also 1400. This one's 200. So I'm going to add up. So my perimeter would be 1400 plus 1400 plus 200 plus 200. Which is going to give me 3,200. So that is my perimeter, 3,200 centimeters. Okay. Number 8, simplify. Okay, so I'm going back to simplify. Now, I do have to be careful when I'm simplifying with this 5 on the outside because I do have to multiply it in a minute. But the square root of 48, I need one of those numbers up at the top in red that will divide into 48, the biggest one. And the biggest one, I believe, is 16 times 3. The square root of 16 is 4 square roots of 3, but I got to be very careful because I've got to multiply that by this 5 that was already on the outside. So I just multiply the 5 and the 4 together. And that gives me 20 square roots of 3. Okay, flipping on over, number 9. Multiplying, though, I do not have to have the same radicand, or the number under the square root sign. Multiplying, I just multiply outside times outside, which is going to give me -6. And then inside times inside. And I'm going to measure 28 times 7. That gives me 196. Now, if you put this as your answer, you would get it counted wrong or partly wrong because I can take and simplify the square root of 196. So I'm going to take 196 and I need the biggest perfect square that will divide into it. I'm going to try to find that. I'm going to go through. Oh, actually 196 is a perfect square. So the square root of 196 is 14. So I'm going to have this right here is 14. So I'm going to have to multiply this -6 times that 14. And that's going to give me -84 as my answer. Okay, is the following number rational or irrational? Pi over 2. Guys, anything that has pi in it is always irrational. No matter what. If it has pi in it, it is irrational. Even though it's a fraction, it's got that pi, that decimal that never stops. It always keeps going. Does the set of numbers below number 11 contain rational, irrational, both rational and irrational, or neither rational nor irrational numbers? Okay, well, let's see. 85 is rational because it's a whole number. 30 over 8 is written as a fraction. We're good there. It's rational. The square root of 16 is actually just the number 4. So it is rational. And then 7.61 is a decimal that ends, which means it is rational. So all of these are rational numbers. 12. Momentum is described as P equals M times V. P stands for momentum. M stands for mass, which is measured in kilograms. Mass in kilograms. And then we have velocity, V, that is measured in meters per second, or M over S, which is a possible unit of measure for momentum. So I'm going to take these units of measure and plug them in. So for M, I'm going to plug in kilograms for M. So I've got P equals M times V. And for V, I'm going to plug in my meters over seconds, because per means to do the division. So if I'm multiplying these, all this is going to look like is I'm going to multiply straight across. This is over, say, 1. So this is going to be kilograms times meters on top, all divided by seconds. And that's what your answer should look like, your unit of measure. Okay, now if we were going to put this like in abbreviations, because sometimes we can abbreviate these units of measure, it would look like kg times m over s. So either one of these is correct. 13. A certain cooking spray has a density of 0.78 grams per milliliters. Which of the following series of calculations correctly determines the mass in kilograms of 17 liters of this oil? Okay, so I need to change 17 liters into these. Okay. So I've got 17 liters that I'm going to start with. And I need to turn that liters into milliliters. So since liters is on top, liters has to go on bottom. And I can go straight to milliliters. Okay. There are 1,000 milliliters in 1 liter. And if I cross out liters, I'm left with milliliters. Okay, which is good. I needed the milliliter right there. Now I need grams. Okay, so I'm going to come and I'm going to multiply. I know that I have, so I'm starting something different, 0.78 grams per 1 milliliter. Okay, so now I need I'm starting to run out of room. So I'm going to need to do if I can move this. There we go, I kind of moved it. Okay. So I need grams on bottom. And I am trying to go to kilograms, because it said kilograms here. And I know that there are 1,000. Oops, that's not the pen that I wanted. 1,000 grams in 1 kilogram. So that's how I would set up this problem. It's not actually asking me to solve, just how would I set it up. That's what it would look like. And then 14, Jackson swam 100 meters in 2 minutes and 30 seconds. If each lap is 25 meters long, which is most likely to be her time in seconds per lap? Okay. So Jackson swam 100 meters in 2 minutes and 30 seconds. Each lap is 25 meters long. Okay. So that means if each lap's 25 meters long and she did 100 meters, that means she did 4 laps. Which is most likely to be her time in seconds per lap. Okay, so we're just really going to take this 230 or 2 minutes and 30 seconds and divide it by 4. So let's change it all to, what about, we need to change this 2 minutes and 30 seconds to seconds. Well, 2 minutes is how many seconds? Well, there's 60 seconds in 1 minute, so there's 120 seconds. Plus the 30 seconds that we had left, 2 minutes and 30, gives us 150 seconds that it took her to go 4 laps. So I can take 150 and divide it by 4 to get how long it takes per lap. So if I divide by 4, that's going to go 3, that's 12, that's 30, that's going to go 7, that's 28. So it's about, let's see, that's 2, I'm going to add a 0, bring it down, put my decimal, 4 goes into 25. So it's about 37.5 seconds per lap here. Okay, 15. How many centimeters are in 7 inches? So I'm going to start with inches. And I'm going to have to put inches on bottom. They give us a conversion. Can I go straight from inches to centimeters? Yes, I can. It's right down here on the bottom. So I can. 1 inch is about 2.5 centimeters. I'm going to cancel out my units. Inches go away. I'm left with centimeters. And then I'm going to multiply 7 times 2.5. 7 times 2.5 gives me 17.5. So 17.5 centimeters. Okay, 3 1/4 divided by 3. Well, a quarter is 0.25. So I'm just going to do 3 into 3.25. That goes once. That's 3. Bring down my 2. That goes 0 times. 3 goes into 25. 7. 8 times. That's 24. Okay, 3 goes into 10 3 times, that's 9. And what's going to happen is this 3 is going to keep repeating. 1.083 repeated. Let me go back. I just looked at the quizzes on the computer, and that is not the actual problem. It formatted weird. This should be 31/4 divided by 3. Okay, so when I'm dividing fractions, I'm going to do 31/4. I keep change multiplication. This is 3/1. So I'm going to multiply it by 1/3. That gives me 31/12. And let's see, 12 goes into 31 twice. That's 24, which means I have 7/12. Is that right? It's 24. Guys, number 16, there is something wrong, I believe, with this problem. Yeah, there's something wrong with the answers. The right answer is not there, so don't worry about 16. 17, if a family of 4 is sharing a pizza, they would partition the pizza into, into how many? Well, how many is in there? They're going to partition it into fourths, because there's 4 people sharing it. Tammy Kelly, number 18. Tammy, Kelly, and Jim love reading books. Tammy read 7.75 hours last month. Kelly read 7.69 hours. Jim read 7.075 hours. Who spent the most time reading? Okay, so the bigger the decimal part, the more time you spent reading. So think about money. Like Tammy would be $7.75. Kelly would be $7.69. And Jim would only be about $7.07. Okay, who had the biggest decimal? 7.75, which is Tammy. 19. Catherine was making treats for a bake sale. She made a total of 50 treats to donate. 20 of these treats were cookies. What percent of the treats were cookies? Okay, so to find percent, I'm just going to divide it's part over whole, 20 over 50. Okay, my zeros can cancel. I get 2/5, and I'm going to divide. 5 goes into 2. It goes 0 times, so I'm going to add a decimal and a 0. 5 goes into 20 4 times, so 0.4 is my decimal. And to get the percent, I'm going to move my decimal 2 places, so 40%. Okay, 20. Which expression produces an irrational number? Well, the first one was the square root of 3 plus the square root of 3. That gives me 2 square roots of 3. Well, that's definitely irrational. The square root of 9 times the square root of 5 is the square root of 45. That is not a perfect square, so that is irrational. I'm not sure if you could click more than one. Yes, you could click more than one. Okay, so this one's irrational because it's not a perfect square. This one's irrational because it's not a perfect square. Okay, let me go to the next one. 18 minus the square root of 64. Well, the square root of 64 is 8. So 18 minus 8 gives me 10. That is rational. Okay, the next one is 13.9 plus the square root of 9. Well, the square root of 9 is 3. So I can actually add those and get 16.9. That's a fine decimal that stops, so that is rational. And then the last one is the square root of 35 times the square root of 15. Let's see what 35 times 15 is 525. And that is a perfect square, I believe. Let's see. The square root of 525 is not a perfect square. So let me make sure I do that right. 35 times 15. So that one should be irrational. Okay, that's 20. 21. An ant walks about 9 inches per second. How many miles per day can the ant travel if the ant travels at the same rate all day? Okay, so I'm going to do my 9 inches per 1 second. Okay, I'm going to convert my inches first. Inches is going to be converted into miles. So that's what I'm trying to do first. So inches, I have no clue. I can't go from inches to miles, but I can go to feet. There are, use another color, 12 inches in 1 foot. Now my inches are going to go away. I'm still in feet. I need to get to miles. So I can multiply by feet. I can go straight from feet to miles. There is 5,280 feet in 1 mile. Cancel out my feet. I'm left with miles. That's what I want my answer in. Now I got to deal with my seconds. I need to turn seconds into days. So seconds is on bottom. It's got to go on top. I'm going to need to move this over. I can go from seconds to hours. There are 60 seconds in 1 hour. So I'm going to cancel out seconds. I want days, not hours, so I have to keep going. Hour has to be on top. I do know how many hours there is in a day. Okay, there's 24 hours in 1 day. I'm going to cancel my hour, and I'm left with day, which is what I was looking for, miles over days. I'm good there. So I'm going to multiply straight across on top, straight across on bottom. On top, I'm going to get, when I multiply 9 times 60 times 24, and I get 12,960, and I'm going to then multiply 12 times 5280. That gives me 63,360, and I need to divide these now. 12,960 divided by 63,360. And that gives me about 0.2, say 0.5. I'm not sure how many decimals they rounded to. Oh, I made a big time mistake, guys. Let me go back. There are not 60 seconds in an hour. That's in a minute. I'm going to have to go, excuse me, guys. In a minute. Ooh, I'm glad I caught that. Then I have to go, so seconds canceled. Then I have to go minutes on top over hours. I totally skipped that fraction. There is 60 minutes in 1 hour. Then I can go from hours to days. My minutes are going to go away. I can go from hours to days. And there are 24 hours in 1 day. Whew. Okay. I forgot a fraction in there. So now I'm going to multiply 9 times 60 times 60 times 24. Now you see how easy it is to make a mistake. 777,600 on top, and then on bottom 12 times 5280. That gives me the 63,360. So I'm going to divide 63,360. That looks better. It's about 12.3. So about 12.3 miles per day. Okay, 22. Find the perimeter of an equilateral triangle. That means all sides are the same, whose sides measure to be There's something wrong with this. 7 square roots of m inches. Okay. So I've got a triangle here. Okay, all my sides are the same. 7 square roots of m, 7 square roots of m, and 7 square roots of m. To find the perimeter, I'm going to add all these up. So I'm going to do 7 square roots of m plus 7 square roots of m plus 7 square roots of m. Now the rule for adding with square roots is as long as my radicands are the same, I can add them. Well, they are. They're all m. So that means I add the outside numbers. So I'm going to add up these 7s. And that's going to give me 21 square roots of m inches is my perimeter. Okay, and then 23. What unit should be in the numerator of the conversion factor? Okay. So what number should be in the numerator? Ooh, gosh. Okay, well, leagues has to go on bottom. And we'd have to look back at our notes. So y'all give me just a second. I'm going to go back and see if it was even in our notes. No, it wasn't. This is something. Okay, let me go back. And I want to get to yards. Oh, well, if I want to get my answer in yards, I was about to say, can't do this. My leagues are going to cancel. And if I want my answer in yards, then what has to be here? Yards does. If that's what I want my answer in, because the other stuff went away. So yards should be on top. Okay, so make sure you've gone through, check these. Go back, rewatch it if you need to. I'm going to post the PDF, this copy, on Google Classroom in case you want to print it out and rework some of these.